Hello and welcome back to the development of the Feersum skiing compiler. So this stream is going to be continuing on where the previous ones have left off. Can continue looking at the implementation of macros. So in the last stream we just about finished off the implementation of macro templates. So hopefully now we should be able to put the macro patterns, macro templates and everything together to actually start defining a macro and having macros in our scopes. And with any luck we will get to the point where we can have some built-in macros that you can actually use. So let's start as per usual by looking at what went on in the last stream. So all the work was in this file, the macros file, which is it's responsible for defining the structures of the macro, so macro patterns, macro templates, and this macro binding structure which we added in to represent a set of captured values from a pattern template, a pattern match. So this is when we have a macro pattern, we try and match it against a syntax tree. We end up with one of these macro bindings which contains all of the captured values to a specific level and then any nested repeats. And we have a parse form, a parse pattern and a parse template which are responsible for parsing the left hand and right hand sides of macro transformers. So the idea is today to put this together and actually start using macros. Just going to resize some things. So in Scheme, let's go and have a look at what a macro looks like. So a macro in Scheme looks like define, syntax, you give it a name, you give it a list of literal identifiers, and then you have the syntax cases. So a syntax case is the one that has the list of literals, and then inside each syntax case you have a pattern. So the pattern might say any number of A's, and then you have a template, and the template may say I don't know, expand that to list, and then each one of those A's pasted back in. Or you could say if there is no A's, so if it's an empty form, then expand it into nil or something. So when this macro is called, if you try and actually use it, you would do something like that, and it would get translated into list 1, 2, 3. And if we tried to do foo without any arguments, it would, well actually I think in our macro system that would also become list, but just with nothing. So effectively what we've got so far is a macro pattern, which is the left hand side in these things. We've got a macro template, which is the right hand side, specifying what to transform the syntax into. And what the bits we need are macro transformer, which is the pair of a template and a pattern, and a macro as a whole, which is basically a name and a list of transformers. And I'm not going to look at parsing them out of the syntax tree like this define syntax case stuff yet. I just want to get it working for built-in macros, and then I can look at parsing at a later date. mainly because I'm not 100% sure how to deal with proper hygiene yet. So you can get the problem where a macro could expand to some syntax on the right hand side that clashes with something that's been defined in the enclosing scope of where the, like if for example down here we'd done define list to be like 1, 2, and then you write foo, you don't want it to get transformed into literally a call to list, because list is being overridden. What you'd want is for this to be expanded into something where this macro was defined and list was still the real like list constructor, and everything would work correctly. But the way our macro system is heading so far, it's not going to be hygienic like that, so that needs some thinking. But I'm wondering if some kind of like representation in the syntax tree of the substitution, in like keeping track of which scope it came from, may help, or some kind of way of uniquifying identifier so you can tell this list from this list. But I don't know. Anyway. Oh dear, Firefox has crashed. This isn't going well. My chat window has crashed. And how long getting is the Twitch broken module page? There we go. So the first thing that we want to define is a macro transformer. So a macro transformer is a pair of macro template and macro, we should put them the other around, macro pattern and macro template. So a macro template is the thing that specifies what the syntax should look like after it's been transformed, and the pattern is the thing that we match. So we can just get away with type macro trans is just macro pattern macro template for the time being, and we'll add more stuff to this if it looks like we need it. And we also want to type for a macro itself. Macro is a list of transformers, and I'm going to make this a record type because I suspect we may want to put more stuff on it later. Type macro is going to be, just for the time being, transformers, which is going to be macro transformer list. So that is kind of enough to check off the first thing here. Let's go and define a macro expand So we've got macro match, and we've got which matches the pattern. We've got macro expand, which expands the template. So I'm going to rename that to macro template expand. No, we can leave that as macro expand. We'd want something else to be macro apply, maybe. So we'll put that before our parsing logic. So we've got all of the expanders, and then so apply a macro at a given point or two. Given syntax node. So macro apply is going to be, I keep on using keyboard shortcuts here that work on Mac OS and don't work on this Linux. So macro apply is going to take a macro and a syntax, and it's going to do, well, what is it going to do? It's going to try and match each pattern in sequence, and then if a pattern matched, expand it, and if no pattern matched, return fail. So how are we going to fail? Ideally we'd have some kind of syntax error that gets returned if someone tries to use a macro. So let's create an error. From diagnostic which takes a location and a string. So we can do syntax location and foo. Trying to think about whether or not I actually do want to parse these so that I can start writing unit tests or not. Let's go and have a look at how we would model this in the syntax tree, in the no, it'd be in the binder. So So in the binder we have this declaration here where we have all of our, which is what we use to build up the scope, the root scope. So this is all a declaration of built-in methods. I mean, it's not the greatest way to get them because you have to duplicate the method name here and the declaration in the library. But for the time being, we can look at that. So let private. What I'm going to do is split out all of these into built-ins. Built-in. So the built-ins is going to be that sequence, and we can also have another sequence for our macros. So these will be built-in methods, I guess. Built-in procs, because technically our scheme calls them procedures. Built-in methods. No. Built-in macros, and we can just have that going to storage ref built-in, I guess. So this is going to, yeah, I think a macro is going to want a name as well as a transformer. So we'll put that in there as well, so that we can, at least for now, we've got a place to keep track of what macros are called, to put them into the scope name. That's going to be m.name. Storage ref macro. And let's open macros up here. Hopefully that means that we should be able to see enough. Yeah, so it's worked out that's a macro. This is a list of macros now. So storage ref needs a macro type. So if we have a macro, that's it. Let's go in the binder. We'll want to actually do something down here. So we need to do seek.concat built-in procs, built-in macros, and then value is not a function. Seek.append, yeah. So basically take all of our different built-ins and build a map out of them. We've got our bindings for the procedures, we've got our bindings for the built-in macros. And we can probably move we can move those what's built-ins. I'm wondering whether or not it might be better to move these this pair of methods from to like builtins dot core procs and builtins dot core macros or something. And does this get compiled after that? Let's go have a look. We are in the binder. Builtins is after. Does the builtins depend on the binder? It doesn't look like it. It just depends on IL helpers. So we can move it earlier. Oh no, we can't. And IL helpers remember depend on. Let's just see. Then in builtins we can have public builtins. At some point in the future it'd be really nice for the list of built-in methods to be scraped from this assembly. So what does load external built-ins do? Load external built-ins takes an external assembly and does find built-in methods. Okay. So we can probably I see one slight issue, which is this map down here. We can move the map back down, can't we? And we can have this as, so this would be core procs or core proc names. And then in the binder we would do built-ins what are we doing here? That thing I just copied. Which I think is starting to get a bit long, and so we'll make that built-in procs again, but local this time. Built-in procs. And let's do some line wrapping for good measure. Okay, that's kind of looking almost acceptable. Built-in procs. And we need built-in macros. So that's just for the time being going to be builtins.core macros, and we'll map it using this. Core macros needs defining. That's going to be public core macros, which is an empty sequence for the time being. So load the core types into the given assembly. It's just going to be the list of built-in macros. Yeah, morning raw. By morning I mean afternoon. It is a new angle because I've switched to Linux and the webcam on this laptop is dire. So I've switched to using an SLR camera on a tripod instead. I need a bigger tripod, but it works. Core macros is going to be I can't spell built-in. I mean, built-in isn't a real word, but I still can't spell it. List of the list of built-in so I think we'll have like a private prox, which is going to be a little bit of what's this going to be? Load core types. Load core types. Why does it need the extern assembly? That's because we use the external assembly in a whole bunch of places. So what I'd want is load external built-ins to be like find built-in methods. And then just importing the reference, because all we actually need here is this up to here. We've just got the attributes for the built-ins. And then find built-in methods on the type. So let's see, how can we rewrite this? So if that's find built-in methods, and then this becomes import built-in import built-in at so we give it the built-in attribute, and it's going to do let's is this really what we're going to be doing? So can't we just do the attribute and the method? Nope. We are getting the attribute and the method. So you have your camera plugged straight into the PC, and yeah, so I just have the camera plugged in with the USB cable, and then I've got a whole bunch of FFmpeg going on that's running in this terminal, capturing frames and piping it to a virtual video device, which is then captured by OBS. I didn't buy anything at all to get this working. It's just what I had written, what I had lying around. It's not my hacker setup. I found a blog post by someone who had already done it. I need to make it a little bit less hacky, so hopefully, like I have to manually mod probe some stuff. Hopefully I can get that to just happen automatically, so the virtual video device is just there. It's using something called V4L2, which is like video for loopback, which, yeah, you need to load the module, tell it how many frame buffers to give everything and that kind of stuff. So hopefully I'd be able to get that to happen automatically. Then the more tricky bit would be recognizing when my camera is plugged in and turned on and having it start the FFmpeg pipeline automatically. That's a job for another day. For the time being, I can just scroll back in my terminal history until I find it and then rerun it. So built-in is going to be at method, and it's just going to take the attribute name and import reference the method. What's wrong there? So we get a list of that. Then we can do seek.map. Import built-in. Is that going to be enough? Nope. So we need some. This is going to be method reference. Method info, okay. What's the other bit still doesn't know. That's going to be built-in attribute. This is a bit suboptimal. And that needs to be namespace qualified. I'd rather not have to do that. Can I do? It's going to produce a sequence, so yeah, I think we've got to do it that way. The idea being here that we now do this can just be find built-in methods. This can become find built-in methods for type. And then this can get extracted into another method, which is going to be find built-in methods extern assembly. So it takes the assembly and does that bunch of stuff, and we can just do that down here. So let's just move some of this blank space around. Whoop, what's gone wrong there? Idea. Find built-in methods on the extern assembly. We could inline that import built-in. What is it really gaining us? Probably not a huge amount. So we'll do fun am to make everything shorter, and then that becomes a.name and then lisp dot main module dot import m. We can get rid of import built-in. Good. So that's looking a little bit neater, and then we can say that core procedure names is going to be load external built-ins, load external built-ins. We have lost the 3 for assembly. That type of cons pair. So we can now say that this is load extern load or find built-in methods, and then map them to. It's going to take the attribute and the method, but it's going to discard the method, and it's going to return the name from the attribute. Good. So that should mean that we don't need to maintain this stupid list of strings anymore. My mouse battery is going to run out. So let's try running some tests. Oh, actually, what's wrong in the binder? What does it think is wrong in the binder? there's still a red. It's in here. Core macros, which is a sequence of macro. But what are you upset about? Core macros is not defined. Core proc names. No, I don't. I want core macros. Let's just assume that you aren't keeping up to speed. I mean, seems like a good guess. What's going on there? Core macros, you're still unhappy about it? What about the actual tests though? I think they are happy. So let's just do the edit it, save it, edit it again dance, which is the most surefire way to convince VS Code that an out-of-date diagnostic needs to get deleted. Right, so what have we done so far, and is it worth committing? So in the binder we've got a macro, in our built-ins we've got the external stuff. We've stubbed out enough to be able to do core stuff. So I'm gonna try and create a commit here for just extracting. So that's entirely related to macro stuff, so we don't care about that. But down here, this is gonna be tricky. Built-ins. Yeah, let's have that. In fact, let's have that. And that. And we'll have this. So everything except for the fact that there's macros here. We'll ignore the macro changes, and in the binder, well, we can revert that one. We didn't mean to do it. We'll have the built-in procs. And ideally, really, what we want is built-in no, maybe not. Maybe what we want is to make built-in macros come first. So we can just do this. Stage that. Let's just unstage everything here. And then we would want this bit maybe. What does that actually think's changed in here now? Built-ins, core prog names. Good. Let's commit that. That's not what I meant to do. Move built-in name. Well, stop enumerating built-ins. Hard coding built-ins. Move or make the built-in module responsible for finding built-in methods. No, cancel. Yes, commit. Commit anyway. I know what I'm doing. Right, then now cancel. So now in the binder, yeah, so built-ins will have core macros. In the binder, we'll have this stuff up here, but also we need to fix up the binder to actually do what we want to do. So that's going to be in bind. Let's just undo all of this. Can I just, yep, that kind of looks like it would work. Why is that indeterminate type? If I had them the other way around, it worked. No. Core macros is a list of objects. Are you just not quite sure what's going on here? Built-ins. So let's try and define some macros, I guess. So that is the thing that we can't do, right? So built-ins. Now can I edit you? Yeah. Macros. 10 macro definitions. That is not quite as central as either one. Maybe. So we will have and macro, which we want to be private. And this is going to be macro. So you just want to give it's something with a name, which is going to be and. And it's going to have transformers, which is going to be a list. And is that going to work? Record label name is not defined. What about, are you happy now? No. What about macros? We got name and transformers. Do we have, we haven't opened macro. I probably do want transformers, right. And then this can be and macro. Do you know what? This should be macro and, I think. So the transformers for this are going to be macro. Well, we want it to be a pair of macro pattern. So an and can consist of two cases. Both of them are forms. So it's either a single thing, which is going to be a variable let's call that A, and the right hand side would be a macro template, and it's going to be a subst A. So if you have a single thing in an and, that's it. What are you upset about? Okay, so this wants to be like that. So with any luck, we should actually be able to use this and have a calling and something and have it turned into that thing. So let's go and actually run the REPL optimistically. I've never actually run the REPL on this machine, so we'll find out whether or not it works. Oh dear, it doesn't. But that is because I've upgraded from .NET 3.1 to .NET 5. Ah, there was only one. Writing a regex for it seems a little bit over the top now. Anyway, back to debugging. It's running. Do we have terminal? We do. So let's just try doing something. Yeah. And then let's try doing and 1. Well, that's nice. What happened here? And expressions not yet implemented. Well, that's a shame. So I think we need to, oh yeah, we actually need to, we've got our macros now in our scopes, but when we call bind, we actually want to be able to deal with them. So let's get rid of and there. So it's if we come here and we call bind application. So it's just going to say, it's going to make a bound application first. So what I think we want to do is We want to see if we've got a macro. So a macro would have to start with an identifier. But what we could do is we could bind the left-hand side first, and if it turns out to be a macro, the applicant, if it turns out to be a macro, do something special. Match, what is this? Find out. So applicant is a bound expression. What about bound expression? Do we know? Bound expression dot literal, no, load. Yes. So we can try matching, if it is a load for storage ref macro. So if it is an expression that refers to a macro, then apply the macro, which means well, what does it mean otherwise? In all other cases, just do exactly what we have been doing up till now. So what do we want to do? We want to do macros dot macro apply the macro we found to we don't have. We don't have quite enough context here. So down here, we can say, we'll have to do it down here, I think. It's because we want, no, here we still don't have the whole full. I wonder if macro apply wants to take this. He wants to take head rest like that, which is going to be unhappy about because It's expecting a syntax node. We could fabricate one. What are you unhappy about? Bound expression. So yeah, we want to do that and then find out if there was a diagnostics. So we'll try and apply the macro. If we could, which would be, and it gives you a syntax tree back, then we would return bind form AST. I think. Yeah. If it was an error, with a DAG, we would context.emit context.diagnostics.emit. So emit the diagnostics and return a bound expression error. Why are you unhappy? Expected to have I see. This needs to be like this to be able to get the type error in the right place, which is that this is not correct. So macro apply, go to definition. We can change, it doesn't actually, why does it want to be a syntax? Because so head okay, we're getting closer. So that should now accept a list. What are you upset about now? Text location. Why is that a binder context? Oh, yes. Okay, so that wants to take, this wants to say bind in context, context AST. Now what are you upset about? Dot. We'll just make another one. In the binder context, we don't have a method that actually just takes a diagnostic and buffers it. So diagnostics bag. We could just have add, I guess. Which just does And then this could be diagnostic. Like that. Add a diagnostic. This should be add. So this should fail because we should get a diagnostic that just says foo, because he's tried to do a macro application and failed when I get to the REPL. So, and 1. Nice. REPL 1, 2, foo. And it is emitting it at the first thing in the syntax, which is what we wanted. So in the macro, try and match each pattern in sequence. So try and apply. So it's going to be macro dot transformers. For each macro transformer, what are we going to do? Macro T. So we want to do macro match T. What else? So it takes a pattern and a syntax node. So that's going to be T dot pattern. So these are going to be pat and the pattern and the template. So we'll try and match the pattern against the syntax, and we'll map the results with macro expand, which takes the template and the bindings. So that should be T, and that should then produce a sequence of that needs to be like that. So this produces something. It produces a sequence of results. So this needs to be bind. Expecting, but given type unit does not match the type string. Why? What? So that result produces a unit. That result produces a string. Right. We also want to do this in a way where we only match as many of the patterns that we actually want to. So let macro id is going to be head on syntax. So we know that this list is always going to be non-empty because you can only ever apply a macro by actually calling it. So there must be something there. So we'll keep the macro ident around for raising syntax errors. Then we're going to say let macro apply once, or macro try apply. So macro try apply is going to take a list of transformers and so we will then just call macro try apply with the macros transformers. So the way we do this is you say match transformers with if there are some transformers, we do match macro try expand one with that transformer. So we try and expand this specific one. If that works, we return that. If if it didn't, if there was an error applying the transform. I don't think we can do this all in one go because we want to distinguish between the pattern matched, but we couldn't expand the template, which is a bad error and we should fail, or the pattern didn't match, in which case we want to continue. So this wants to be macro match. So we try and match the transformers. So this is going to be PT. So if we try and match the pattern, and we got some bindings, we'll return macro expand the template with the bindings. If there was an error, we will do macro try apply rest. So that's the case where we need to recurse and try the next pattern, or if we're out of patterns, we need to return an error of no pattern matched the syntax. So what's going on here? AST node, macro match, P. Yeah, we actually need to pass the syntax. Good. Right. What are you complaining about now? But it has type AST node list. I really wish this was a real piece of syntax. Macro match is, I guess it's actually, if it's a form with a list of patterns, seriously beginning to think that this might want to be we could pass the whole form through to bind application by doing this. So just make bind application which, oh damn it, it's still a list at bind form. I forgot about that. Where's bind form get called from? could just pass the whole node to bind form. And then here we get the list, which is the form, and then this can be node.location. Then down here, this could be node.location. This feels bad, but hey. I'm gonna copy this. Oops. Come on. It's making it worse. Then bind. Do that. Go back to having that like that. But we can pass the node down. Bind application. We can use the node here. Syntax, right, and then syntax is list ahead. We'll just say match the syntax B. That's bindings. This needs to be result.error because we accidentally aliased that. Okay. Macro try apply. There's going to be macro. Yeah, this needs to be recursive. Try and apply the rest. That needs to have a pattern. Right. So this will either return no pattern matched, or it will return the error string from expanding it. So what we want to do here is to match that with if it was okay, which means we managed to get an AST. We will actually we can just do result map error on this, can't we? Because we want the okay case to be the same thing, which is just the syntax tree. But what we're going to do in the case of the error is take the message that we've got and turn it into a diagnostic. So that's going to be result map error, and it's going to take the error message and produce a diagnostic using syntax location and the error message, and then I think that's it. What's wrong? Macro transformers, macro. Do I need to say this is a macro? Apparently so. transformers. We should probably rename that. Did I just make the same typo? Apparently not. I just only renamed in one place. Good. So what would we expect now? Maybe it'll work. I've lost track of what we've done. No. It needs to compile first. What's going wrong here? Expect it to have type list. Go to definition. So you got node. What we're doing node, we're passing it to macro apply, which is apparently expecting a syntax list. Why is it expecting a syntax list? Because macro match expects. We call syntax location. I think that's a lie. Object does not define the constructor, remember. Okay, how about if M was a macro? How about that? Expected to have type obj. Why is that a list of object when it's a list of macro? Typo. I should have just left it as transformers. Is that going to work? Yes. So right to I wonder if some of these things can't get read or written to, like we've got the built-in and we're gonna have macro in here where we say storage ref macro and then fail with can't redefine macro. Then we want to say if it was a macro, can't use, or just invalid. Valid macro application, but the trouble is that these are actually compiler errors rather than, we should have a way of turning these into diagnostics rather than just throwing like that. But Hopefully that works. Why are you so sure that this is a list of objects? Builtins.core macros. Right, now, can you turn that? You can. Do the tests run. I'm guessing that is yes. So let's try and run it again. If this works, I'll be incredibly impressed. So and, which is the macro defined, 1. We'd expect this to expand to 1. No pattern match the syntax. Why is that? Built-ins. Let's have a look at our built-in, and it is because we want macro pattern dot underscore, which will match anything. Let's do this again. It's close though. So if it matches, what happens? Really wish you would stop showing me the debug console there. Right. And 1. 1. And 1, 2. No pattern match the syntax. Nice. So let's try. The other case in the macro pattern here is going to be if we have a macro pattern which is a form we've got an underscore, we've got a value and we've got repeated variable. And what do we want to do in this case? So if we've got a match for this, the macro template, it should be macro template. We've got to make a form. And inside the form, we're going to have macro template element dot template. So basically, we're wanting to rewrite this into an if, where we say if the macro template dot quoted so if it this is going to be AST. Oh, this is going to be really awkward because now I need to make a fabricated syntax node. We could do with a way of parsing these things so I don't have to write this all by hand, but you know what? Yeah. So it's going to be quoted AST. Well, we make an AST, so that is just done by doing. Do we have syntax fact? We don't. So quoted here is going to be something that has a kind of node kind ident, and the ID is going to be if. This is really awkward, and the location is going to be text location. Missing for the time being. Or we could just set all of the locations to syntax.location. Oh, we don't have syntax. Yeah, it's gonna be text location dot missing. And we need to open that as well. So we'll make a quoted ident, and then the next thing in the form is going to be the condition. So that's going to be macro template element template macro template dot subst a. So that's the first variable, and then the next thing is going to be if it is true. So if it is true, it's going to be a macro template element template macro template it's going to be a form. And the form is going to have a macro template element. This is so tedious. Template, macro template dot quoted of this needs to be an AST now. So kind is AST node kind dot ident and location text location missing. So it's a quoted and And then the next thing in the form is going to be a macro template element dot, finally something different, repeated element, and the repeated element is going to be a macro template dot subst for the variable b. And then the final thing in our outer is going to be a quoted false. Macro template element template macro template dot quoted, and then kind, here's t node kind dot bool, a constant dot bool. Oh, syntax constant dot boolean false. So it's a false with text location missing. That kind of almost should be it. So let's try that and see if it actually works. That is a long pattern. Nope. Macro template. Well, fair enough. Close enough though. Macro template. And 1 is 1. What about and 1, 2, 2, and 1, 2, 3, 4, and whatever. Yeah. How about something that isn't? So and 1, 2, false, 3, 2. How about and 2, see the absolute there is one other case we need to handle here. What is going to happen here? No pattern match the syntax. Fair enough. So the last one is macro pattern dot form macro pattern dot underscore, which we could just shorten to just match. We could just match the whole thing with an underscore. Is that too lazy? No. Macro pattern dot underscore. So anything else gets expanded into a macro template dot quoted of kind ast node kind dot constant locate. Oh, this needs to be syntax constant boolean false location text everything else just becomes false. Which the only other possible thing that you could have by the time you get down to here is an empty one. Let's try and boom. Right, and something is that thing, and basically what do we consider to be falsy in our if? I think it is. But I think bind if or if. Come on. If. Bound expression if. Okay. If. So I think it is just if true. So it duplicates it. If it is a boolean, it goes to not bool. And so it's truthy if it's anything other than the boolean false. So let's define the OR macro. This is going to be a lot of copy and paste. Macro OR. So the name is OR, and the transformers are this basically, but with trues changed to false. So if we see an A, you return, if there's only one thing, you return that thing. If there's nothing, which is this one at the, we return true. I think. Let's just, yeah, if it's nothing, let's go dig out the spec for this. Or is difficult. Standard libraries. So the test expressions evaluate from left to right. If any expression evaluates to false, then a false is returned. That's what ours does. Any remaining expressions are not evaluated. That's also what ours does. If all the expressions evaluate to true, the value of the last expression is returned. If there are no expressions, then T is returned. Okay. So that's not quite what ours does. So an and with nothing needs to return true. Okay. An or. The test expressions are evaluated from left to right, and the value of the first expression that evaluates to a true value is returned. If all expressions evaluate to false, there is no expressions, then false is returned. How do we do this without reevaluating things? How on earth do you define an or macro? You really don't use it anywhere else, do you? Some of the macros are defined at the end of the language spec. You really do want it to return you really do want him to return the first truthy value, because you can use it to like provide default values and stuff. But I can't think of a nice way of doing that without introducing a local. Anyway, an or of nothing is false. I think that's what we just said. I've closed the window. And false if there is no expressions. So we can do that. If there's only a single value, we can return that. What do we do in this case? think of a really hacky way. What we could do I was thinking of a hacky way by changing what a single an if which only has a condition and no and only has one branch in it returned, but we need to handle both cases. This is just really awkward, so how about not handling it until we can pass macros? Because to write the macro for it wouldn't be too bad. You would say something like define syntax or syntax case. It would be or of something is itself. Or of something is itself. Or when its own is false. And then or with 1A and some B's is if, well, begin, define a cond or something to be A, then we've evaluated A to something, then we can say if A, return A, otherwise return or of B expanded out, something like that. But given how much of a faff it was to just write the equivalent of that for the and, I think I'm going to ignore that until later. So we should write some tests for the and macro though. So let's go find the specs folder. Macros or built-in macros. And we will just copy over the examples from using and in I didn't copy things because I used the wrong shortcut. Come on. Firefox, help me out here. I'm actually right-clicking and pressing copy. Why are you not working? Could it be that the editor has died a little bit? Maybe. Let's just write them out by hand. The cases are and. Yeah, the editor's died a bit. Reopen, please. So the cases are, and come on. Two, and greater than 2, 1, which we'd expect to be true. And so let's display that. And we're going to do the display list thing because that way we get nicer formatting. And equals 2 less than 2 1. That should be false. And 1 2 C quoted F G. Interesting, which should be, I guess, FG. This on its own should be true. Right, so let's run the tests, and these are going to fail because we're going to get some new parser stuff happening. Two failures. Snapshot does not exist, and a snapshot does not exist. So task, no. Run task. Update snapshots. What have we got snapshot wise? Come on. Some parser stuff. Nice. And the output is TFFGT, which hopefully matches up with what we expected. TFFGT. Yep. Right. Built-in macro support. Initial work to make macro expansion work possible. Defines a built-in macro for and. Defining still can't spell built-in. Built-in macros is super unergonomic. So we can store macros in scopes, and we have a built-in macro for and, which I'm going to count as completing that one. Right. So thanks for watching, and that's it for today. So in this stream we've had a look at actually allowing macro expansion in the language. So we added support for having macros bound in our scopes, created a default set of bindings which contains a macro for and then changed the binder to expand out the macro if it encounters a call to the macro. And hopefully in the next stream, we should be able to add support for defining macros in Scheme itself, and that should make writing some of these built-in macros a little bit easier. But that's all for the time being, and see you next time.